Here we go.
Is this an easy unit?
I mean, if you pay attention, I think all these units are pretty easy.
But is this one easier than the other?
I think so. This one's keeping all the properties straight. Okay. Okay. So, folks, class has started, so it's time to stop talking. I need you to look forward and get to writing now. We're starting notes, okay? Let's go. Eyes up front, please. So, what is a polygon? We've heard this word before, all right? It's something you've probably heard since elementary school, probably maybe even before elementary school for some of you. Who knows? Okay? But there is an actual adult definition for it, okay? Not just like it's a shape. It's more than just that, okay? So first of all, a polygon is a closed figure, okay, made up of connected segments, okay? And of course, what do we call those segments? What? Lines, or, well, I mean, in a shape, what's the segment? We call that the side, right? It's a side. Okay. And no sides cross. Okay. So we'll draw a couple pictures here of some polygons and then some things that are not polygons. Okay. So I'll draw some things here up on the board and you guys can tell me, polygon or not. Okay, so polygon or not? Polygon. So this shape here, that's a polygon. Okay. What about... Sorry. What about this shape? Polygon.
Looks like half a ribbon.
So as long as all the sides are connected, they're not tied.
As long as they all meet. So,
Not a polygon.
why not?
Because it doesn't have sides.
Right. A polygon is made up of connected what? Segments. A circle, right? A circle, it's closed, right? It doesn't have any like gaps in it or anything like that, but it's not made of segments. It's not made of segments. Okay? It's a circle. So a circle is not a polygon. Okay? No curves. Okay? All right, how about, let's see here. How about that?
Not a polygon.
Why not?
Because they don't all meet.
Right, it's not closed, is what we would say there. It's not closed. Okay. How about, I don't know. This? Polygon, right? Okay. Okay. Kind of looks like a trapezoid, right? One more.
No.
Right. The sides intersect. Whoops.
What about this one?
No, because it's got curves. Okay, so there we go. So we have some examples and some non-examples, okay? More importantly are the non-examples because you want to, kind of understand, helps us to understand like what's not a polygon. Okay, so we'll talk about the parts of a polygon. Okay. So I'll draw a polygon over here. And we'll put some labels on these points. Okay. Okay, so the points are called vertices. Okay? These are points. Yes. Yes. Is that good? Okay. Vertices, these are points that define the polygon. Okay, so we're going to use that vocabulary here. We're learning quite a bit of vocabulary today. So vertices. We've heard of vertice before, though, or vertex, right? That's the singular form. Right? We have angles. Angles have a vertex, a point. So like the point of our shapes, the point of our polygons there, those are vertices. Okay. Right, what about, well, we also have our sides, of course, right? And these are the line segments that connect the vertices. Okay. And we also can talk about diagonals. Okay, a diagonal is a line segment that connects two non-consecutive vertices. Okay? A line segment that connects two non-consecutive vertices. And I'll kind of pause here because I'm sure that I'm going too fast. So I'll slow down here. Okay. So non-consecutive vertices. So, for example, let's talk first of all what it means to be a consecutive vertex. So let's talk about A. What would be a consecutive vertex to letter A, to vertex A? What would be consecutive to that? Alex?
I would say
B or F. Why? Well, you're right. Yeah, it's like the next one after A. Either going this direction, it would be B, or going the other direction, it would be F. They're consecutive. So then non-consecutive to A would be what letter? What vertices then? C, D, or E. Yeah, C, E, D. Exactly right. And so a diagonal then would be if we, for example, had a segment that connected A to C. That is a diagonal. Okay, but a diagonal would not be from A to B because what's A to B? It's just a what? It's a segment. It's a side. It's a side of the shape. Okay. So there's an example of a side, and then here is an example of a vertex. Okay. Now we name polygons much like how we name triangles. We just say polygon, and you can start here at A. Okay, and then you can't just like name any random combination of letters, you have to do them in order. So if I start at A, I either need to go A, B, C, D, E, F, or I need to go A, F, E, D, C, B, okay? You can either go clockwise, counterclockwise, or clockwise, that doesn't matter, but you have to go in order, okay? You can't just like do random letters. You can't be like A, D, F, B, E, C. You can't just do that. You have to put it in the order that the shape is in.
What if I make them all A?
Okay, so like that. But you don't have to start at A. You could also start at B, and so you could say, you could name it B, C, D, E, F, A, or B, A, F, E, D, C, okay? Or you could start at D and go D, E, F, A, B, C, or D, C, B, A, F, E. It doesn't matter. So you have a lot, okay? You have a lot of options, so I'm not going to, like, name them off there, okay? But you have a lot of options. Okay? It's whatever order you want. All right. Classifying polygons. So now that we know about polygons, so we can talk about, for example, polygons can be equilateral. And we know what equilateral means. What does equilateral mean? Anybody? All sides are congruent. Okay? Yeah. Polygons can also be equiangular. Yep, all angles are congruent. I'm running off this page here. Okay. And then if something is both equilateral and equiangular, it's one of the silliest names that we have in geometry, but we call it regular.
Equal shape.
Okay. I think it's silly because it's actually such a, to me it seems like it's such a special thing to be both equilateral and equiangular, and yet we just say that's regular. Okay, so be both equilateral and equiangular. All right. So far, so good. Question, anything? All right. So then we also have another way to classify polygons. We have concave, like we talked about earlier. Okay. And so I'll just just draw some examples up here, okay? Okay. So there's an example of a concave what? What type of polygon is this? Quadrilateral, Mr. Widmeyer. Good job. Okay. Believe it or not, there's actually a name for this kind of quadrilateral. Okay, that's concave like this. It's called a chevron. Okay, which is also a company too, and the company has its logo is a chevron. Okay. So it's like which came first, the chicken or the egg? There, I don't know. I would imagine the name Chevron probably came first, and then they just adopted it. Okay? So again, the basic idea here is that you can think of it as being like bent in, okay, or caved in. That's why I like to think the word, if you're like, how am I going to remember this? Just think concave, okay, one of the sides kind of caved in on the shape there. Okay, that's what I think of. And then convex, well, that's the more typical kind of polygon that you see. Okay? You know, that's like a rectangle, or a square, or that pentagon. Okay. All right, so those are convex. All right. We also need to be able to name polygons. We kind of did that already, but we're going to do it formally here. So we'll make a little table here, number of sides and name. Okay. So, three-sided polygon is called a triangle. Okay. Four-sided?
Quadrilateral.
Quadrilateral. Hope I can fit this all on here. All right. Five-sided shape?
Pentagon.
Pentagon. Okay. Six-sided shape?
Hexagon.
Hexagon, that's right. Anyone here take Latin? Yeah? Okay, so Latin for six is... Oh! Let's see here. Good thing it's just water. Just water. Jordan, go back to your seat, please. Yeah. Thank you.
So Latin for six is
Sex, right. So another name for the hexagon is the sexagon too, okay? So.
Oh, you should just
Say again?
You can't come back from that.
Yeah. So, and Addie, if you need to go to get more paper towels,
Turn around.
I'll get you one. If you want to go to the women's restroom right there, the business one, it's one of these two keys. You can unlock it if you want.
One of those keys.
Or if you want to just wait, you can wait too. Oh, okay, that's okay. You get more water, come back, and then we'll clean that up. Okay. All right, and then 7 is the septagon or heptagon. Right, I'm going to use hepta, but you can say septagon. I will not take points off. All right, 8-sided.
Octagon.
Octagon, again, like October. Octagon, like October. October would be the 8th month if we subtracted off 2, right? Because, again, we added the July and August for Julius Augustus Caesar.
Take a guess for this. Navagon?
Nonagon.
Navagon? Nope.
Nonagon. Okay.
Decagon.
And then 10 is decagon.
What's 11?
11, I think, is an undecagon. I know a 12-sided shape is a dodecagon. Dodecagon. So, but you don't have to worry about that. Anything after 10 sides, anything after 10 sides, okay, we're just going to call it an n-gon for the number of sides that it is. So, for example, if we want to talk about a 100-sided polygon, we're not going to come up with some weird name for it. We'll just call it a 100-gon, okay? Or if we want to talk about a 50-sided polygon, we won't come up with a name. We'll just call it a 50-gon, okay? And that way it'll just be easier to name. You will need to know these names. What's that? After 10, just the number of sides gone. So, for example, if you have n number of sides, just call it an n-gon. Okay? So yeah, an 11-sided shape is an 11-gon. A 15-sided shape is a 15-gon. Okay? So, for example, a 100-sided shape, we'll just call a 100-gon. Okay? Just to make it easier for ourselves.
Gone out the door. They were done.
Okay, now, the interior angle sum. Of a n-gon. Okay. Well, remember, we know the interior angle sum of a triangle, right? What do the angles in a triangle add up to?
180.
180, okay? What about for a quadrilateral? Do you guys know what a quadrilateral? 360, that's right. So we added a side, and we went from 180 to 360. We added a 180 degrees. What about for a pentagon, though?
720.
Not 720, nope.
Also 360.
Nope.
480.
540, how'd you get that?
Because there's another one.
Another side we added, and we're going to add another 180 degrees, and that's exactly right, okay? If you add one more side, so hexagon, okay, you're going to add another 180, so 540 plus 180 is going to give you now 720 degrees, okay? So, in general, right, what if we don't have to keep adding those 180s? Well, in general, the sum of the interior angles okay, of a polygon equals n minus 2 times 180, where n is the number of sides. So, for a three-sided polygon, that is a triangle, right? 3 sides minus 2. What's 3 minus 2? 1 times 180 is 180. And so, sure enough, the angles in the triangle add up to 180. For a quadrilateral, 4 sides. 4 minus 2 is 2. Times 180 is 360, which is the number of the sum of the interior angles of a quadrilateral. All right, so let's do a quick example with this here. So, what is the angle sum of a decagon? Okay, so we'll ask, what is the interior angle sum of a decagon? Interior angle sum of a decagon. Okay, so let's see here. So, Donovan, how many sides does a decagon have? Decagon? You need to know that.
Wait, how many sides and how much the angles would add up to?
10, okay? Shh. Remember, deca, think of like decade, right? A decade is how many years? 10 years, right? The decimal, that's base 10. Yeah, that's all I can think of right now. So, decade, 10 years, decagon, 10 sides. And so, for our formula here then, if we want to find the interior angle sum of a decagon, we're going to do 10 minus 2 times 180, which is then really just 8 times 180, which is then 1,440 degrees. So all the angles in a decagon have to add up to 1,440 degrees. Yeah.
So if you can relate decagon to decade, why don't we do 100-sided polygon?
It could be. I don't know. That might be the name for it. For our purposes, though, rather than memorizing all these other names, we'll just stop at the decagon and then just say from there. But that could be the name of it. I mean, they do have names for like other polygons. I just don't know. But a centagon would make sense, though. Yeah, it's crazy. So now, here's the next question. What is the measure of a single angle of a regular decagon? Okay, so a bit of a different question. We know the sum is 1,440. All the angles in a decagon have to add up to 1,440. Okay, but I'm asking, what is the measure of a single angle in a regular decagon? All right, so let me just think about that for a second. Okay, I'm going to call on someone. So again, think about what we could do here. We know the sum of the angles of a decagon. How can we find a single one? So don't shout it out. I'm going to call on someone and see what we can come up with here. So let's go to someone who's here. So Addie, what do you think? How can we find a single one? If we know they all have to add up to 1,440, how many angles are there in a regular decagon? 10. And all 10 of those have to add up to this. So how can we find just one of them? No idea? Eli, want to help her out?
Divide 1440 by 10.
Divide 1,440 by 10, right? If there's 10 of them, and since the shape's regular, what do we know about all the angles? All the angles would be what? Equal, the same, right? And so if they all add up to this, and they're all going to be equal, divide it by 10, and then you know what the interior angle has to be, a single one. So yeah, it'd be 1,440 divided by 10. 144 degrees.
Yay.
Could we find the measure of a single angle if the decagon was not regular?
No.
No, we could not, because we don't have enough information then. We would need to know 9 of the other angles, and then we could find that 10th angle. If you guys remember, back when we did our similarity unit in our review, I gave you guys... Actually, I got all of them right here. Yeah. Remember back in our review here from similarity unit, we had these two shapes and they were similar, and there was one angle here that we had to find on our own. I think it was angle K, right? Because it didn't have its corresponding angle C there that we knew. Well, now we know how we can find angle K, because what kind of shape is this? What polygon is it? A pentagon, okay? So a pentagon has to be 5 minus 2 times 180 has to add up to 540 degrees. And so we could subtract off, this angle's going to be 85 because it matches to that one, right? This one's going to be 105 because it matches to that one. And so we can subtract off all 4 of those other angles to find this missing angle C, which would then be the same as angle K there. So, you know, minus, what is it, 105, minus 115, minus 110, minus 85, and so 125 is what that missing angle has to be. Okay. And of course I didn't give that one to you because we hadn't learned this yet. Alright. So, let me see here. Okay. So yeah, so any questions on any of that? Any questions on any of that? All right. So let me give you guys your assignment then. Okay. There's 2 things. Take one of those. One more about the soul. Say again? You loan me, Jordan? Yeah. I'll be there, Josh. 1 second, bud. And then one of these. Good job. You each get one of those too. They're and then also take one of these after that.
Oh, that's I guess confusion.
Take one of those. Pass it down. Take one of those.
Or is it?
I don't know.
Okay, your assignment. Alright, so there's two sheets I gave you. The Intro to Polygons sheet, okay? I would like you to do... Great. Alright, 1 through 21. So you can skip number 22. All. Okay, and then the polygons and angles one. I want you to do numbers 1 through 10. And one through 10 and 21 to 30, and try number 32 as well. Okay? So there's your assignment. Okay, you have a good amount of time to work on that. Tomorrow we're going to be hitting quadrilaterals hard. Okay, we're going to hit quadrilaterals hard tomorrow because the majority of this unit is going to be spent on quadrilaterals, four-sided shapes.